I'm an inventor. To put a finer point on Anton's introduction, I run a philanthropic lab. People bring me problems. Dr. Ming, my daughter has 500 seizures a day. Please save her life. Dr. Ming, my son can't enter REM sleep. Dr. Ming, our company has bias in its promotion process. Can you help build an economic model to actually price the cost of these bad promotions and help us argue it to the board? Our country doesn't know what to do about education policy. Can you come in and help us figure out, because our test scores keep going up, but our human capital doesn't seem to be improving and our citizens aren't being employed. What's going on? And if I think my team and I can make a meaningful difference, I pay for everything. And whatever we actually come up with, we simply give away. It turns out it's the world's worst startup idea. Infinite demand, zero revenue. It's the costliest job I've ever had, but it turns out it's the best job in the whole world. And it also affords me the opportunity to play around with technologies. And in some cases, I'm fundamentally a lazy person, but in some cases, invent that technology to try and make a difference. Nobody calls me first. They go to an actual neurologist. They don't call the crazy lady in California. So once they've reached me, it's a simple assumption. Nothing else worked. So let's start from scratch and try and come up with a new solution. So I'm going to talk about some of the new solutions I've worked on since the last time I had the chance to visit Cape Town or Johannesburg. And let's start with one obvious one that I didn't work on, but I have had intimate interactions with, which is GPT-4. So it's just released. This is OpenAI's cutting edge, and many would have us believe, with good reason, world-changing artificial intelligence. A recent study showed that you could give GPT-4 many of the standardized exams, such as law school entrance exams in the United States, standardized high school or university exit exams, and it performs essentially in the top quintiles, top 99th percent in many of these assessments. So now we live in a world of true human-like intelligence that isn't human, except that that's not true at all. What you have, as I think you were walked through in the last presentation, is an incredibly powerful tool, but it's still just a tool. The metaphor I sometimes use is a craftsman or an artist in their tools. With these new tools like GPT-4, we are amazingly empowered. And without them, we will be hobbled, at least for the world that is our potential future. But we have focused so strongly, not just in South Africa or in the US, but I can say with a lot of experience all around the world, we focus almost exclusively on the tools. And again, tools, if you don't have them, you're hobbled, but tools without an artist is pointless. And I'm going to echo one other previous comment, which is, but I'm going to put it in slightly different terms, maybe provocative terms. Technology is inevitably inequality increasing. And that's something that is very salient in the United States, but not only here. And the reason for that statement is the people that actually need it the least are the ones that are best able to make use of it. It's simply a truism on some level. And so I know from my own work, you can invent AIs to use in education. You can develop new technologies, new methodologies for finding amazing new employees or discovering health technologies. And on day one, your customers are none of the people you had in mind when you invented these technologies. Your customers are wealthy, well off, they already own the world. And now you've given them a huge advantage. And everyone that you truly were hoping to benefit, they are justifiably skeptical because all of their life has told them that this isn't going to pay off. And you have to overcome that. So I'm going to get grounded and talk about some actual technologies. But I wanted to start there, just by echoing where we left off. Inventing something doesn't change the world. What changes the world is owning the whole problem, remaining problem-focused in trying to understand and develop solutions. We get so invention first. And again, to echo one more point, metaverse. What problem was that ever meant to solve? This talking to you through a camera is, I will be honest, this is a pretty mediocre experience. If you will forgive my bluntness, this is a pretty shitty experience, but it's quick and easy, as opposed to putting on some VR rig and climbing into some device and trusting, as a neuroscientist, my vestibular system to Mark Zuckerberg and hoping that somehow we have a transformative experience. Be honest, I'd rather just fly there and take the 22 hours to reach you. It's a solution in search of a problem. And in my work, that gets you nowhere. If you haven't moved the needle on the problem, you haven't invented anything. So one last lead in, and it's doing some work for me. I've actually been interviewed by ChatGPT, the immediate predecessor of GPT-4. It was the most boring interview I've ever had to sit through. I mean, it was more fun because it was done with the Financial Times. They'd ask me these phenomenally boring questions. It clearly knew who I was on some level. Let's be clear, echoing previous comments, it doesn't know anything. It is the world's most sophisticated autocomplete. Really, that's not an insult. That is literally what it is. It doesn't know anything, but that amazing power of learning the statistics of human language creates the solution. It knows who Vivienne Ming is. And then it went on to ask just phenomenally dull questions that didn't advance anything. What made it more fun is then I got to explain, why do I think that question was generated? And what's wrong with it? Where could we take it from there? When you're building these things, it has to be in your mind that we need to take it further. And in fact, in the context of education, some of you, if you are interested in AI or education, may have seen a number of university professors posting online. Oh my God, I gave my final exam question to ChatGPT or GPT-4, and it gave perfect answers. And I went through and I read many of those answers. Because years and years ago, nearly 20 years ago now, I built an AI that could listen to students and predict the grades they would get in the class. So I was genuinely interested in what was going on here. And I looked at their answers. And much like the questions for me in the interview, these reminded me of the answers I would get from my students at university, where they clearly picked up all of the words. They got all of the surface features that we were talking about. And it went about 1 millimeter deep. They didn't understand anything. I would talk about this with other professors. We called it thought salad, where they picked up all the phrases. The great thing about ChatGPT and GPT-4, at least it gets the punctuation right and spells everything correctly. You'd think by the time someone's a grad student or an undergrad, they'd have a handle on that, but hell no. But in this context, at least you can read these things. But there's even these amazing postings from these professors. I read them and I thought, forgive me, this is the American grading system, that's a D answer. That is an answer. It isn't an F, it isn't an absolute failure, but it is at best one step above that. Technically, we call it a normative answer. It said all the right things, but without actually evidencing any understanding at all. And I was able, in fact, in that project we did a couple of decades ago, building AIs to listen to students, looking at what actually predicted a failing grade or a mediocre grade or an amazing outcome. And the interesting thing is when we listen to students just having free-form conversations, when they gave those D answers, all the words were correct, they didn't say anything actually wrong, our system predicted they would come out in the middle of the class, even though literally everything they said was 100% correct. It was the students that explored, the ones that took an idea that was talked about in the course material and took it someplace else, and often said the wrong thing. Amazingly enough, when they explored the unknown, they made mistakes. They were the ones that were predicted to come out at the top of the class. Right now, AI is a D student. And in fact, I tell this, I just gave a talk to a National Association of Educators here in the United States. And I said, if you're scared about this, just give all of your students your essay questions ahead of time. Let them plug it into ChatGPT and tell them that's the D answer. Now your job is to create some actual meaning and go further than that. Your job is now to explore the unknown. All right, so all of that rambling nonsense was set up. Let's get into some specifics that I've had the chance to work on over the last couple of years. And I'm going to start with something that's incredibly important to me. It started out of a conference at MIT I was at just before the pandemic started, where we were looking at genetics. And someone had taken mice and they were able to turn on and off individual genes in the mice and dramatically change their behavior, but like one specific behavior at a time. And it made you wonder who we are. Are we our genes? Are we more than that? So a bunch of us at this conference got together and said, what if we mashed up your genetics with my epigenetics? So this is the ability of your body to actually turn genes on and off. You think genetics is complicated. You've ever gotten a profile at 23andMe. Oh my goodness, that's just the start. It is orders of magnitude more complicated than that because your body can turn off the individual genes over time. Your experiences as a child can turn these genes on and off and can, in fact, be carried over to the next generation. So high stress childhoods turn off genes associated with cognitive development and turn on genes associated with aggression and vice versa. So epigenetics, neuroimaging, hormones, behavior, using artificial intelligence. Can we look at all this and find out everything we are? And riffing a bit off of the idea of GPT-4, can we bring in large language models and understand? And at the time, I was working on language models to predict suicide risk from people on social media, people with legitimate risk of ending their lives. And sure enough, we found by listening to them, using these models, we could identify people who are at much greater risk of committing suicide, people who are experiencing major depression, people with bipolar disorder, all treatable, but left untreated, threatened to be the last days of someone's life. We mashed all of these technologies together and a variety of things have emerged out of them. I'm going to talk about one, combining large language models, something like GPT, with epigenetics. It turns out what we're able to do when we put these together is do something no one's ever been able to do before. We have the first ever epigenetic test for a mental health disorder, postpartum depression. In the United States alone, about 3.4 million women will give birth this year. and 15% of them will experience postpartum depression. And in about 1% of them, they will have something called postpartum psychosis. And if you've ever watched a terrible movie or seen a horrible news story about a mother doing something terrible to her children, that's postpartum psychosis. This is what happens when your mood states get yoked to your hormones. And obviously it doesn't affect all women, but what we found is in your epigenetics, if you have a particular allele of a gene and it's turned on, we could actually see your mood states tracking, not just during pregnancy. This is one of the things that was so amazing. We could look at young women that had never given birth before. And in this case, based on Twitter. This was before your local boy bought Twitter and drove it into the ground. So he's an interesting guy. So, but back when everyone was there, we could actually watch these women sharing things online. And we found, somewhat amazingly, their stress levels. We could model stress and a variety of other things right out of their tweets. By the way, this was all done with their permission. These were all women being treated for major depression. But we were looking back in time, long before they'd been diagnosed. And we could see their stress levels going up and down like waves on the ocean, very patterned. Well, I don't know if anyone can guess the period of that wave, but I just gave you a hint. It was 28 days. We looked at dozens and dozens of women who, after the fact, had eventually been diagnosed with postpartum depression after they'd gotten pregnant, after they delivered, and we went back earlier in their lives, and we could see that their stress, as measured by an AI, was following a 28-day period. Essentially, their mood states were being driven by their hormones, and that became a huge predictor. So now we have a test we're about to release here in the United States. It costs $99, and an app that costs absolutely nothing. And of the 3.4 million women that get pregnant, the nearly 500,000 that will go on to have postpartum depression, it is the most common complication of pregnancy. Much more so than gestational diabetes or preeclampsia. For the first time, there will actually be a diagnostic test. And the stage 1 is free, because that's one of the amazing things about artificial intelligence, is it allows you to change the economics of problems. And maybe the least sexy way to think about AI, you want to think you can go play with DALL-E or GPT or GPT-4, now mashes them together and create images, and you saw many examples of them. You get lots of flipper people. This is still a technology that doesn't quite understand fingers, but hands are hard to draw, let's be sympathetic. But in actuality, the real strength of AI for the near future is it's the world's most complex actuarial data. It's not that it's 100% perfect, because it isn't. It's that it lets you become the house. It lets you get precise odds on the world that has come before, on the routine. So for us in medical diagnostics, to be able to look at, just in the United States, the nearly 500,000 women that will experience postpartum depression, and confidently go to 60% of them and say, you don't have to worry about this. This is not going to be a part, or all of the women that will be pregnant, you don't have to worry about this. It will not be part of your future. We can really focus on those who are at risk. And furthermore, deploy it again at no cost to reach the vast majority of women, for example, in the United States, that don't have obstetricians and may never see a doctor during their pregnancy, and yet be able to help them and direct them to care. Because with no support, their lives and miserably. Just in 2017, postpartum depression, just in the United States, cost $14.2 billion. Our economic models indicate we can trim about $10 billion off the top of that. And that's dollars. You have to understand what we're talking about is changing the lives of those families, and particularly the kids that are so dramatically affected. That's just one example. Using artificial intelligence and epigenetics together to do something truly unique. And that's just a starting point. Some obvious things, we could go out and do something you may not have heard of, which is menopausal depression. And also hormone-related Alzheimer's. Alzheimer's occurs more commonly in women, and almost twice as many women as have postpartum depression will go on to have perimenopausal depression a little bit later in life. We're already indicated that we can identify those women, not just before they enter menopause, we can identify when menopause will actually start in them through a menopausal clock, artificial intelligence, plus epigenetics. I just want to throw out one more fun thing. If you have a favorite team, it could be a little, this is my ball signed by your ex-captain here. And if you've got a favorite team, or maybe it's football or soccer, and you're thinking, well, I don't have a menstrual cycle, so I don't need to worry about any of this stuff. We played around with our data with the guys and found actually they show the same sensitivity. The men that had this epigenetic predisposition to hormone-related mood disorders looked very much like the young women with the same, but instead of following a menstrual cycle, what we found was it followed a game cycle. If your team wins or loses, your testosterone spikes or drops. By the way, this is also true of women. So if you're a total freak for sports, this happens for you as well. And I'm talking about testosterone because everybody's got it. Your testosterone spikes when your team wins almost as much as the actual winners of the game. And it drops if your team loses. And if you have this epigenetic predisposition, your moods track right along with that. So guys, you have your period. It's just, it happens to be. So just, you know, and maybe we can treat that too, but it could also be that just being a guy is just going to be a lifelong disorder you're going to have to deal with. All right. I saw some smiles on the appropriate faces there. So, so we have this just as a starting place, and I've got so many more things I want to get through. I probably need to speed this up a bit, but it doesn't have to stop here. We're now working on a new idea. I like oxymoronic phrases because it captures something of the insane aspirational approach that I take throughout my life. So here it's precision public health. We want to take a public health approach to disease, which is to say, intervene before someone has an acute condition. But we want to do it unique, because when I look at the room, even through my crappy Zoom image here, I see a room full of very different people. And there's no reason that we should tell all of you to do the exact same thing for the sake of your health and your cognitive health in the future. So we're actually beginning to explore using artificial intelligence and, yes, epigenetics and neuroimaging to develop this precision public health concept. And we're already looking to target diseases like type 2 diabetes and ischemic heart disease because they don't have to happen. Because we can intervene earlier in your life, and by changing your behavior, change your epigenetics before the disease ever presents. Will this end these diseases? Of course it won't. But the point is, as I said earlier, the most boring and yet truly effective way to think about machine learning and artificial intelligence is it's the biggest actuarial table in the world. And now we get to play the odds. And if we can reduce the prevalence of type 2 diabetes in the population by sending targeted behavioral interventions to individuals long before they ever actually diagnosed, even with pre-diabetes, then we have changed an entire society. This is the number one human capital cost after salaries for all of Southeast Asia. And in the United States and in South Africa, type 2 diabetes and ischemic heart disease, principal drivers of mortality and morbidity. We can look at changing that by rethinking how we're conceptualizing our connections with the world. I'm going to do one more on explicit artificial intelligence before I jump into a couple of other new emerging technologies we've had chances to play with. And this is something that's not actuarial tables. And it's a little nerdy, so I'm only going to touch on it, but it's causal modeling. Right now, even the most sophisticated models in the world, like GPT-4, are giant correlation engines. What's amazing, if you're a scientist like me, is how far statistics can get you. Pure statistics, listening to English language, listening to all languages in this case, turns out can produce something that seems very human-seeming. But we, actual humans, we don't just learn by statistics and correlations. We build models in our heads. We call it model-based and model-free learning, and it's a big part of what makes us intelligent in the world. In fact, even some simple animals out in the world have more sophisticated model-based learning than the most sophisticated artificial intelligence. Your dog can quickly learn that in one view that flipping a light switch will turn a light bulb on and off. In fact, babies can learn it. Their first experiences with a light switch, you can clearly show that they now understand there's a causal relationship between the light switch and the light. And they're surprised the next time the switch gets thrown and it doesn't happen. But no AI does that. We're now in the space where we're experimenting with this in a number of projects, both in precision public health, but we're also looking at modeling the policies that drive economic growth within communities, particularly through high growth startups, but also looking at events and interventions inside of companies that are causally related to things like productivity growth, employee turnover, and trying to predict performance of the company over time. Causes, not correlations. It hasn't been a strength of AI. And again, unless someone really wants to ask me a question later, I'm not going to get into the mathematics of it, but essentially we can turn our futures into a giant game and use the mathematics derived from economics, where they do lots of causal modeling, to look at the experiences being had inside your companies and identify what events are causally related to changes in productivity across the company. And that is incredibly exciting because we can essentially do it for free and watch these events happening over time and essentially allow you to run experiments and see what's going on inside your organization. So it's been really interesting to be able to try and absolutely push the limits of what's possible, trying to understand what's driving the world, not just what the world has been in the past. So I said we're going to talk about some other technologies than just artificial intelligence. And one of them that's very different than much of what I've talked about so far is milk. You may not think of milk as a technology, but being able to have a food source was a huge advance for humanity back when we first realized, oh my goodness, we can actually grab a whole bunch of these goats and cows and take them around with us, and always have something to eat and drink. The problem is, particularly those dairy cows, when you combine dairy and beef cattle together, they are the largest source of agricultural greenhouse. It is a serious climate issue. They just eat so much grass and fart and fart and fart, and it's a problem. So what could you do about it? Well, you can make nut milks. We do a lot of that here in California with almond and oats and other things. It's a perfectly fine ingredient, but it isn't a milk. Not in the sense of being produced by mammals and having particular qualities. And one thing you can't do is make cheese. But what if instead of milking cows, we milked yeast? So the same way that we currently make biological insulin, which is genetically engineering yeast and other microorganisms to produce insulin, which can now be done synthetically. But for the longest time, that was exclusively how it was done. We can now do this with milk. We fill up milk, giant vats with nutrients. We're doing this right here in Berkeley with nutrients populated with genetically engineered yeast that essentially excrete milk. And then we skim milk off the top of this. And it's milk. It is biological milk. You can make cheese with it. You can dry it out and spread it on toppings. If you're buying, chips at the store with cheddar cheese flavor, in the not too distant future, that's not coming from a cow. That's coming out of a vat full of yeast, which produces a tiny fraction of the total emissions produced by cattle and requires vastly less land. Trust me, we don't have a lot of land in Berkeley, so if we're making it here, it doesn't require a lot of land. Although the company that is commercializing this is also developing it out in India and in Indonesia with production facilities there to share. Think of all of the kinds of ingredients of our lives that could be produced as a biological instead of an industrial process or a traditional agricultural process. One of them could in fact be oil itself. And yes, right here in Berkeley, we are working on a similar approach, in this case using algae to grow oil. Industrial grade oil being put out by algae. And again, it floats up to the top and you skim it off. These are two examples of where genetic engineering is coming up against two domains that we don't traditionally think of as biomedical: milk production, foodstuff production, and industrial oil production. But that's where we're headed, where we can do this with vastly lower carbon footprint and literal space footprint by turning humble little yeast into an industrial factory. It is genuinely amazing. And I have to say, my first introduction to this was actually as a neuroscientist. It is one of those truths that to a molecular neuroscientist, all of you are roughly yeast, which is to say at a molecular level, some of the protein cascades in yeast and the cell membranes in yeast pretty much look like a neuron in your brain. Why screw around with neurons when it's so much easier to work with yeast? And so a lot of molecular neuroscience goes on with yeast. But we can actually take that a big step forward. In recent years, we've developed out a concept called an organelle. And if you've never heard of this before, what we are doing now, particularly in neuroscience, is growing brains. Now, these brains are tiny. You can grow them big enough that you could see them. but essentially they're little micro brains, but they're actual human cells. And when we grow them, they have dynamics. The cells communicate with one another. They essentially behave. Now, for us in experimental neuroscience, this is great because we can study the cell dynamics without having to stick wires into cats or give macaques rabies retrovirus or other things that are, no one actually wants to do animal experiments, but there's no other way to do this. But that's not true anymore. Now we can grow these organelles, but it doesn't just stop with brains. One thing that's extremely exciting to me is growing an organelle pancreas. Again, biologically, it behaves like a real pancreas. Why is that exciting? Even though it's this little barely macroscopic thing? Because your pancreas makes insulin. And as I already mentioned, type 2 diabetes is a scourge of humanity. But my son has type 1 diabetes, the less common kind that's not a lifestyle disease, which is unfair, but in fact is an autoimmune disease. His body simply can't make insulin. His immune system destroys the part of the pancreas that does that. No insulin, you can eat all you want, you will still starve to death. So he takes insulin shots, very expensive insulin shots. That keeps him alive. In some places, with well-financed healthcare systems, that becomes a part of your life. In other places, you hoard insulin. You take less of what you need. You can't eat because you don't have access to the insulin you need to prevent that sugar from building up in your bloodstream and eventually killing you. So now we're looking at a future where we can build an organelle pancreas and put it in you. And with an additional advance, surround it with a biosynthetic sheet. Essentially, you make almost like an astronaut of biological matter, which we can embed in you, and it makes its own insulin and puts it out in response to the natural sugar levels in your blood. For years, and I've had the chance to talk about this before in South Africa, one of my claims to notoriety is I hacked all of my son's diabetes equipment, broke all sorts of US federal laws, and developed the first ever AI for diabetes 11 years ago. But now we're looking at a potential cure. Being able to build little organelles, put them in your body, and let them actually naturally interact with your sugar levels in your bloodstream and produce natural insulin in response. It is an amazing advance. And organelles probably sound really scary. We're growing brains, tiny ones, and we are doing exactly that. But this is also a chance to radically transform the future, not just growing milk and industrial oils in vats in an industrial part of Berkeley, but actually embedding these systems inside living human beings. And for people who've had disease take away part of who they are, be able to give it back. And it's a huge and amazing advance. What else are we working on here? I know I'm starting to run a little long and I had so many more things. Are you trying to cut in here, Anton?
I'm trying to tell you we're getting to a Q&A soon, but sort of 5, 6, 7 minutes max.
Perfect. Let's keep it quick then. No more deep dives. I am joining a big project. I'm building a smart city in Singapore. And this is a huge look at what it would mean to their aspiration, and this is part of why I'm involved, is good governance, is to build an ethical approach to building data systems that can transform people's daily lives. And everything we can collect along the way, and how do we make it secure so no one can break in and steal that data. This is a big new push. The idea of smart cities have been around for a while. Singapore is uniquely positioned to make a push that is hopefully doesn't lean into the authoritarian, but still allows us to benefit from the massive collection of data. And one of the ways I'm approaching this is I've just started a new company. I have 3 neurotech companies right now. And in one of them, we are collecting enormous amounts of very intrusive information. And I believe my value proposition as a company is that if we do our job right, people will be alive that wouldn't have been alive otherwise, and they will be living good lives. I so much believe that's our value proposition, and that we don't need to resell their data, that we've developed another new technology. This is a first in the world for a private company. We've built a data trust. It is an independent institution that owns all of the data being generated by our users and has sole fiduciary responsibility to the users, not to us. We use that data with permission. And by design, then from day one, no matter what happens, who takes us over, whether we get bought, whether we change our minds, we'll never be able to sell our users' data, because that's not our value proposition, and we don't need to make a difference. Instead, the data trust gives us automatic auditing of our data and algorithms, which every organization should be doing, including the project I'm working on in Singapore. And it allows us also in the United States, I'm going to be very blunt, to shield the company from subpoenas from states that might want data, for example, on women's menstrual cycles. Nope, you can't have it. We don't own that data. All of it's encrypted, and we are taking this step from day one. And the wonderful thing is our investors have seen the value proposition, because why would people share their most intimate lives if they thought it would ever be abused? And the unfortunate track history with virtually every company is eventually someone will come along who will abuse it. I don't have to view myself as a perfect person. I need to set up a company where we can be that better organization from day one. Another one of my companies is using neurotechnologies for creativity. We've developed a device, you put it right behind your ear, it monitors your brain states while you're online or reading a book and identifies the world as you see it. So we're moving now, not from just search in a classic Google sense where you type in keywords, to potentially, though this is still pretty iffy, natural language search with technologies like GPT, where you can have a conversation and learn through the massive data integrated capabilities of the world's biggest autocomplete. But the next big stage is for that search to understand you, for that search to actually be a conversation in some sense with yourself. Former postdoc of mine started this company. I'm on the board, and we are looking at how we can actually build models of ourselves so that when we are going back and writing and creating, we can go back and explore the world, not through an avatar trained on the entire internet, but through a model that represents explicitly how you think about the world. And oh my goodness, I'm going to end on one more topic. This little box behind me, one of my companies is jointly based in Berkeley and Copenhagen. Another former postdoc of mine. This box is a light. You can read a book by it. Our eventual ambition is that this very, very fancy light, may not look like it, but trust me, it is, will be built into computer screens. Why is that exciting? This box treats Alzheimer's. Even though you can't tell while the box is turned on, it just seems like a normal light. It actually induces modulations in your brain at 40 hertz and 8 hertz. And in our most recent tests, it increases individuals with mild to moderate Alzheimer's. It increases the volume of their hippocampus, the part of your brain involved in long-term memory, one of the most susceptible to Alzheimer's, and improves cognitive performance over a 12-week period. Doesn't just slow it down, improves it. So this is incredibly exciting. I'm also eyeing a study whether this can be used to help treat or prophylactically treat major depression and cognitive decline earlier in life with individuals when maybe they're still in their 20s, and furthermore with children that have traumatic brain injury. Taking kids that have been in car accidents or, God forbid, abused, and being able to give them back their life simply by reading a book with a particular very fancy light turned on next to them, or again, built into a computer screen, is a huge ambition for us. This has been a quick or not so quick tour through some of the cutting edge technologies I've had the chance to work on. And I'm gonna now prime you with one last comment that if anyone does have questions, we can take it to the technical. We can get into how do we make certain technology doesn't increase inequality, because that is a big part of my work as well. But I want to end with this, to echo again our previous speaker. Here's a fascinating truth. Intelligence, as traditionally measured, like IQ or G, it predicts a lot of things. It predicts your lifetime earnings. It predicts where you'll go in your education. But intelligence doesn't predict happiness. It's really fascinating. Happiness has been studied for an incredibly long time. And there are different kinds of happiness. There's hedonic happiness, which the name may give you a clue. That's how you feel when you stuff yourself full of chips and beer and you're just feeling gross afterwards. But at least while you're doing it, you're feeling good. And then there's eudaimonic happiness. That's probably best described as that feeling of a job well done. It's not something that is a BAM kind of experience. It's something that grows over time as you move forward through life with purpose. Turns out eudaimonic happiness is associated with positive health outcomes, hedonic happiness with negative health outcomes. So just being happy doesn't mean you're healthy, but being smart doesn't mean you're happy. What's going on here? Here's where I want to end with an interesting idea. What GPT-4 is truly good at, AI is truly good at, is statistically modeling the known. Everything that has come before, even finding some interesting connections amongst the known. But what it's not built for, literally by design, is exploring the unknown. Another nerdy way of putting it is there are well-posed problems that have explicitly right answers. And there are ill-posed problems that just don't have a right answer. What's the answer to 2 + 2? Well, what's the answer to happiness? It turns out GPT-4, as I told you up at front, is amazingly good at answering well-posed problems. Vastly better than the average human being. And it can do it right off the bat, from law to mathematics to art history. But it can't answer ill-posed problems. It can't find happiness, partially because it in fact just is turning numbers into numbers and doesn't understand anything. But looking in ourselves, what makes us special? What makes humans still unique in the world is that we can explore the unknown, that we can challenge ill-posed problems and make a difference. Everything I just talked about, and there's so much more I could have, those are all tools. None of them is a solution to a problem. None of them represents technology's ability to explore the unknown, to answer ill-posed problems. That is still entirely on us. One of the things I want to end with here then is rethinking.
Last ending, Vivienne, last ending.
Absolutely. Rethinking your organizations for how we are prepared when the actual human value add is that unique ability to explore the unknown. As the routine disappears, how do we transition all of our employees and our citizens into a world where I don't need them to follow directions? They will never follow them as well as an AI. I need them to have ideas that I would never have had myself. That is a dramatic change, and one we are still not ready for.